Hello all, welcome to Ambari Cloud YouTube channel. And today I will be presenting how to export a Snowflake data into Parquet format. But while you're exporting, are you going to export into a single directory, all the data files, or multiple files, multiple directories based on your partition key? This is an essential decision you have to make while you are exporting Snowflake data to build Open Lakehouse. So I'm going to walk through the steps needed and how you achieve converting a Snowflake table, permanent table, to a Iceberg partition table. But while you are exporting, then you have to make decisions. Should I export into all the files into one directory, or based on the partition key? How you achieve that one through Snowflake code? Then after you export files to cloud, and then how you're going to convert into an Iceberg table. That's what we're going to discuss. Okay. Well, so just quick review on the architecture. Snowflake has permanent tables, and then we're gonna export them into Parquet files, and then we can convert into a Snowflake catalog table, or you can make it as a object integration catalog table from other tools, Parquet files. There are many combinations. I have uploaded these videos already, and you can look at how to build a Snowflake catalog table or object integration catalog table for Iceberg. But here our goal is export and convert into Iceberg table, and then that Iceberg table can be integrated with the Snowflake catalog, or it can be integrated with upcoming Polaris, or maybe Glue, or Hive catalog, or Cloudera Hive catalog, or Nessie, whichever you want to. Right? That's not the part of this use case here, but here we're going to export and create a Hive. Create Iceberg table using Hadoop catalog. Then after that, you can register wherever you want to. Okay. Snowflake is introduced already, but it has some issues as of today. And but Polaris is becoming more popular. Right. Here, you export files and then you integrate those files as internal Polaris catalog, and then after that any REST tool can read that data. Okay, so convert a Snowflake table into Open Lakehouse Iceberg table format. That is our goal today. When you're migrating from Snowflake to Iceberg, assess if the Iceberg table needs partitioning. If it is not partitioned, it's easy, just export and then create an Iceberg table. But the challenge is to build a partition table. Okay, so non-partition Iceberg table is straightforward. However, creating a partition Iceberg table involves additional steps. So first, export the data as Parquet files. Ensure while you are exporting, anyhow you are using the Snowflake engine, right? And then make sure the data files are co-located. The data is co-located. So do order by using your partition key in your select statement. That way, then all the so your rewrites will be faster. Then we have better performance. So always remember, when you are exporting Parquet files, use order by. And if you are planning on doing a partitioning, and look at your partition keys. Okay, there are two options for exporting. So export all files into a single directory. But if it is a very large file, right, or very large tables, actually, it's not file. I would avoid this. Too many files in one directory in cloud is not a problem, but too many files, right? So try to build a pre-activity, creating kind of a partitioning directories. Okay, export file into separate directories based on your partition key. Okay, So for example, if you export a customer table, then you're going to export everything into one directory. So here, while you're exporting, you have to build your stage. So stage is pointing to your cloud location bucket, based on your external volume and then the base location. So look at how to build a stage in Snowflake, how to build a external volume, and then look at the integration, all the stuff. In the previous videos, I have the examples, but that's not that difficult. So if you look at in this example, I'm exporting the test underscore 1b table is a 1.5 billion table. While exporting, then I'm also doing data type change. So yes, this is where you need to look at it, mapping the Snowflake data types to data types, like number versus decimal and variant versus string. Those are the things you have to look at it. Okay. Then here we are exporting in a Parquet format, and then you build your Parquet format. Then the formatter, you can use snappy compression. Then header equal to true, where in Parquet files, then it will keep our column names. If we don't put header equal to true, then it is going to create some fictitious names. Then you will have issues when you do for Spark reading. Okay. Then export to partition key directories. Let's say your partitioning is partition key is, for example, nation number 1, 2, 3, 4. In our example, then you will create a separate directories 1, 2, and n. Right. So then and again all related partition key data is in one location, and those files. So that way, in the future, when we do rewrites and when we do the add files, then those things I'm hoping it will be faster. So same thing here, only different, same thing as previous export copy into, and then but here the select statement is same, but only thing is you're using a partition key here, and make sure if you have multiple, of course, sometimes you have multiple partition keys, for example, state, or look at the cardinality. You always have to have low cardinality keys first. So here, we are using a nation key, and you see it has low cardinality, and then we are using a partition key here. Okay, so let's walk through steps. First, we need to create a Snowflake stages, right? Then create a Parquet file format. These are best practices. That way, because you can reuse these same formatters. And then stage, you have a base stages, or maybe a separate stage for every table, whichever way you like it. And then export table into one directory, and then export data into partition key directories, as I said, based on your design. But I suggest do some testing. The same table, one directory, same table, partition key directories. That way you will have experience how to build a partition key table based on one directory versus partition key or Iceberg table as based on one directory, Iceberg table based on multiple directories. Okay. Then of course make sure to order the data based on partition keys, and then that way it's co-locate related data. Then from Spark, and so connect to the create a Spark session, and then use Hadoop catalog. You can also use Glue catalog, but what if you're not using Glue, or what if you want to use Polaris, what if you want to use Hive or Nessie? So the general practice I suggest is, again, it's my experience. We always convert Snowflake to Iceberg table on a Hadoop catalog. Then once you create a Hadoop catalog, all you need to do is wherever you want to register based on your catalog. So as I said, use a Hadoop catalog, and then run add files. Now, if it is a single directory, it's a run all files from in the entire directory. But here I want to emphasize, when you create Iceberg table, make sure do not create a partition Iceberg table yet. Okay, just create non-partition Iceberg table. Okay, and then run add files procedure, and then after that add partition key, right, or keys, and then make sure that your order is very important. Then of course, since you already done here, then you use the same thing. Then run maintenance procedures, which is rewrite data files. The partition key, differently you need to rerun data files. That way they need to adjust the directory structure. Then run express snapshot, because you're running the rewrite data file is going to create another snapshot, and then you don't want to previous history. So just keep only one single snapshot. That way then you will have a fresh start. Okay. So what are the catalogs you're going to talk about here? We want to register eventually. Once you're done, then you can use glue, Polaris, Hive, whichever you want. Okay, so that's what the procedure. Okay, so let's look at here. I have a bucket by Cloud Satya, nothing there. Then let's go to the Snowflake. Then I'm going to have some test data. Okay, I'm going to run. So I'm creating a test table. It's coming from this 1 billion row table. Okay. Once the test table there. So what will I do is I have a stage for customer 4 table and a stage for customer 5 table. So this is a non-partition table and this is a partition table. As I said, you need to build stages. Then for that, you need to build your storage integration. Storage integration is based on your external volume. External volume is mostly how your Snowflake is connecting to your cloud bucket. Okay. And so let's wait for run because this big table, we are creating it. Okay. So here, if you look at the code, create a stage, right? And then again, I have multiple stages, one for the customer 4 table and customer 5 table. Then I'm going to, so these stages are created by an admin user, and then I'm granting to, this role. These are RBAC practices. You will have a user at admin level doing all these stages or volumes and everything. Then you're going to give it to individual users. Okay. Then I have stages already created previously. Then here, Parquet format, I'm going to use snappy compression. Stay with the snappy because if you use different compressions, other tools may not work on the Parquet files. The safe bet is always snappy. So now I'm going to create a non-partition table. Okay. So here, if you look at, since this table is so big, right, and I don't want to create 1.5 billion just for demo, so I'm creating only 2 partition, then data. So let's going to run this one. Okay, I'm going to run. Then make sure that header equal to true, right? Because you need to have the column names matches to this column. Otherwise, if you don't put header equal to true, then it will create a fictitious column names in your Parquet file, and then you will get it. It will not work. It will show nulls. Okay. It took a while for me to find out that issue. Okay. Now customer table, and then I have a data files. Okay. Parquet files, right? One directory. Now I'm going to do a partition, right? So I'm going to do partition by. Okay. I'm going to do that. Exactly same code. Only thing is partition by. Okay. Let's run this. So nothing fancy here, copy into your stage, then your select statement, then your partition key, your format, and header equal to true. Okay. Now let's go to here and then keep refreshing. Okay, so customer file directory is creating, then go to data. Now if you look at it is 2 directories because we are using only 2 partition keys. But if you have, actually this table has almost 20-40 keys. So my intent here is to show that we have separate directories. Okay, and so now we have a files ready, right? Now I have 2 tables. Now the tables are ready. On the files are ready. Now what we need to do is we need to attach these files to an Iceberg table. Okay, let's get into Iceberg. Here, okay, let me export all files into one directory. We did export files in separate directories based on partition key. We did, right? And I have some helper function. Give me all the subdirectories of a table. Right? So I'm here. I asked the ChatGPT, give me how to list subdirectories for a given bucket and prefix. Then I got this method already in 2 minutes. Okay, I did not write it. ChatGPT wrote it for me. Okay, before you start, since we are using AWS, make sure that you export your credentials, and then so here export all files into one directory. That is the one example. So now I have files here, and the directory, and so I don't want to run this one. Yeah, well, let's run it. Okay, now when you run it, you will see all the files in here, right? We saw that one already. So here I'm using AWS boot, right? If you look at here, boot 3, then running AWS S3ls command. Okay, now I'm going to run my Spark session. Now if you look at here, this is my Spark session. Then I'm using Hadoop catalog. Then of course my catalog name is local, just any name. Then my credentials. Once we have that, then I'm going to create a database, right? Now here I'm using a Spark catalog. I'm going to create, and then once you create my database ready, then I'm going to create a customer table, customer 4 table. Then I'm going to drop it, make sure that if it is, and then I have a prod database namespace. We created a prod database namespace. Now what we're going to do is we're going to create an Iceberg table pointing to customer 4 directory. Now here I'm using, cow table, again, based on your use case, cover more, choose whichever way you want to. Okay, now let's run this table. Okay, now I'm going to describe the table. Now the table is created in this directory here, customer 4 directory. Then it is owned by Iceberg. And then let's check if there is any data here. And okay, no data. Then just look at the metadata directory. Now since we created a just empty table, it created a metadata JSON. Now let's go here, customer table. Then it's created a metadata directory and then 2 files because it's an empty table right now. Then what we're going to do is we're going to attach those files to the table, right? So here, add files, okay? And I'm giving the directory, data directory, and I'm going to run add files, okay? And I'm going to run count on the table, and then, I'm going to run just few rows. Okay, so here what is happening, right? Is it reads each and every file, right? And it builds the metadata, which is meta layer for Iceberg. We already discussed in various demos previously about meta layer, manifest list, manifest files, and manifest list basically is a snapshot, and then manifest file is location of your data files, and then okay, this is our data, and then we are looking at here. Okay, now let's go to, now look at the data directory. Now is simple files here, right? And what we're going to do is we're going to run a partition key. So alter table, add partition key. Okay, we added the partition key. After adding the partition key, right? And let's run this guy here, refresh. Nothing changed. The directory structure is same because we haven't loaded any data, and then so the practice always is whenever you modify a schema, always rewrite data files. Okay, actually you can you can run the entire files, or rewrite the entire, rewrite all. You can do that, or you can keep the same files as is. Then, but here, very most important, always rewrite data files. Now let's do the rewrite. So what the rewrite does is, right, now the data is on one directory. Then it takes, it need to know that each file, which partition directory is supposed to go. Basically, because we already did order by, and then it reads the file. Okay, this file goes to one directory or 19 directory because we have two partition keys. Okay, let's wait for that. And let's go here. Still running. Yeah. This is a bit, I'm using very single node cluster in my laptop. So from my laptop to AWS is very slow. But if you are using EMR cluster, this process will be faster. Okay, let's run it. Almost there. We have 32 stages. Yeah. So as I said, right, whenever you change the schema, always run the rewrite the data files. That is very important. It's a standard practice. Okay. Now, if you see here, right, and then these files will be copied into, again, they're not moved, right? I'm reiterating that one. Now, these files are copied based on the partition key is going to copy into these directories. Okay, why they are not moved? Because we need a time travel, right? So the first schema is non-partition. The second a snapshot is partition. So that's why they're not moving the files. They're going to copy the files because a snapshot is immutable, right? And so here the 72 files, and then since we set the different size, right? And these files are not only combined into bigger files and then moved into particular directories. Now let's look at here. Okay, this is original table, and we attached it, and then we create a new snapshot. And then let's look at the data files. Now if you look at here, nation 1, nation, like this, the files are distributed previously. Let's look at all files, for example. Okay, now if you look at here, right, just all files. Look at all files. Okay, now if you look at here, the files are there, all files, because these are part of this snapshot. Okay, so once we're done, right, then what we're going to do is, and we're going to expire any snapshot older than this date. So we're going to take, here, we're going to expire it. So we want the most recent snapshot. We want only this snapshot. We don't want any more here. So we're going to expire. Let's run, expire. So what is the expire does is going to delete all these data files because we don't need it, right? Because we already have a new rewrite bigger files. Okay, now look at these files are deleted, 72 files. Now let's look at this file path. Okay, now we're gonna only see, now let's run the all files. Okay, right? let's run all files star. So all files is almost equal to your data files. Okay, and I'm going to put file path easy. Yeah, so now you see that, right? So previously here you see the these files, and now after expert snapshot, then all the files are the. Now let's go back to okay. Now data directory. Now only you see these files with directories. Then when you go to directory, you have the files. Previously we have the files under data directory. Okay, so this is how you're gonna build your the Iceberg table based on a single directory. Okay, now let's go. You already exported into multiple directories here, you already had it like that. Let's say, for example, if an external table was built like this, and instead of export, if somebody already built your table directory by directories, then how are you going to build? How are you going to convert these files into Iceberg table? Now let's do this one again. As I said, create another table, but don't create a partitioning yet. Okay. Now here I'm going to get my subdirectories. Okay. Now if you look at, I have two subdirectories, 1 and 19. Okay. Then what we'll do is for each subdirectory, I'm going to run add files here. So I take each subdirectory, and then this method is basically takes each subdirectory and then run the add files. So here I got the list of subdirectories. Then I'm in a loop. I'm going to execute this stored procedure. So this not this Python procedure. Then we're going to run. Now let's run this. I'm going to run one more time. Now here I'm executing. So each subdirectory I'm running a add files. Now if you can see that once it is executed, right? So subdirectory. So we're going to add first add files of this directory. So if you have a whatever directories, doesn't matter, it's automated here. So this directory files are added. Now we're going to execute. So here, if you do manually one by one, then you have to execute like this. Okay. You have to execute, but we just wrote a. Now keep in mind, I have asked ChatGPT. Okay, this is my path, my bucket, and this is my path, and then find the subdirectories, and then write a method to add files for each subdirectory. Then finally, this all the code is done in 5 minutes using OpenAI. Okay, so now once the files are added, now let's go here. Nothing changed, right? And now we're going to do same procedure. We're going to run add partition key. Then we're going to run just check the data files, how many data files we have. Okay, 59 data files. Then we're going to run add procedure. Okay. Sorry, rewrite data files. You're going to run the rewrite data files. Again, same procedure. Alter the table, rewrite the data files, and then expert snapshot. Okay. Now we then rewrite. We'll see here. Now these directories are still there because of the time travel, right? And once it is done, then we will see partition directories. And then again, as I said, these files will not be moved. These they will be copied into a partition directories. So here I'm showing based on your situation, if the files are already partitioned by directories, or if the files are all in one directory, how to build an Iceberg table. And then I'm also showing in Snowflake how to export files, the permanent table data into Parquet files in a single directory or multiple or n directories based on their partition key. So the idea here is migrating Snowflake into OpenLake host. That is the idea, right? Lift and shift. Then this Iceberg table you can register with EMR Glue, or you can register with Cloudera Hive, or you can register with Polaris. And then any other Spark, Apache Spark engine can execute your Iceberg table. That is the, but still, or you can connect to this Iceberg table to your Snowflake as object integration Iceberg table. Then you can use Snowflake engine. So, but we are opening basically we are building the open lake house. Then many tools can execute on this or Iceberg table. So let's say Snowflake is managing it. That means Snowflake is doing update, insert, deletes. But EMR just can read it. So or other tool, or maybe Cloud Array reading it and doing the ELT, ETL work on it for tables. Okay. So let's execute. Then let's check it here. Now look at this one. Start creating the directories. Now if you see the files here, and then of course then we will also see the files in this directory. And then once this part is done, right? Okay. Now if you look at data files 15, then what we're gonna do is, okay, we will expire. So anything older than this, okay. So that means we're going to delete all these files, or will be deleted. Okay. I'm going to run one more time, make sure. Okay. Okay. Now let's check the data files. Okay. And then now we are seeing that. Now let's check the all files. Okay, 15, same. So this is how you're going to convert your Snowflake permanent table to Open Lakehouse Iceberg table. And if it is the files are already partitioned by date, or okay, now look at here. There are some files are still there in this directory because it's not fully converted because of the size, right? So some files are still this particular file data is still in not partitioned yet. So you might have to rewrite one more time in a bigger way. Maybe let's do that. Okay, I'm going to rewrite some bigger file here. Okay, because when you rewrite, right, don't assume all files are combined, because because it has a limitation of file size, right? Okay, so let's do rewrite. Then just check the snapshot ID. Now here, let's check here. So it's rewriting on the same directory. Once the rewrites are done, okay, this is a very big file, so the stage will be slower. Let's wait a couple of minutes. Okay, let's check what's going on behind the scene. Yeah, it is running. Okay. Yeah, make sure when you rewrite, make sure all the files are, so you look at this one, the 14 files changed to 2. These are very big. Now, let's check the, now I'm going to expire anything older than this. Okay. Now if you look at here, then still there is one file dangling here. Maybe we need to look at all files. Yeah, there's still file. This file is not getting merged, but yeah, we may have to look for another rewrites again. Anyhow, so coming back to the whole goal is how to convert a Snowflake table into Openhouse Iceberg table, and then key is when we want to do partitioning. Whenever you change schema, make sure rewrite your data files. Very important. That is, otherwise, it will not impact your data and all this, but you may have performance issues. Because when you partition it, you want to, data moved into partition directories. Of course, future data definitely goes to partition directories, but existing data, you need to make sure to go to partition, then it only take advantage of the hidden partitioning and partition pruning and all this stuff. Now the table is ready and you're using Hive catalog. Now then you can register this table either in Glue or in Polaris. Of course, Polaris is still having issues. As I said, add files. As of today in August 22, add files is not working. They're fixing it. Then you can register in Hive, or you can I have Hive of Cloudera or EM or Glue, and then watch other videos where I have described how to register a table. But I'm going to walk through very quickly. So let's go to the Iceberg test cases. Okay, YouTube Iceberg test cases, and then the 1D. So let's go to 1D, right? Register. So here, all you are doing is, you're registering your table using register table, right? You have your customer table, right? Let's run this one, okay? So this method is going to give me the latest JSON file, and I'm going to open a Spark session to Glue using Glue catalog, right? I'm going to save here, and okay, I'm going to show databases. Then I'm going to create a database called prod, and then of course I'm going to use prod in Glue. Then I'm going to create a table, right? Customer for table. Then I'm going to say, again, I'm going to drop the table if there is, and show tables. There is no table here. Then give me the customer for table metadata JSON. Yes, this is metadata JSON. What we're going to do is we're going to register into Glue catalog. Okay, and then of course I'm going to register there. Then I will ask the show tables, right? Then I'm going to query data from my I should have used limit 10 is big table, right? Now let's go to Glue. Okay, let's go to here, Glue, and then go to Glue catalog. Then I have my customer table, right, ready to go. So the customer table is pointing to. So now I can query this table from Glue, and going forward, Glue is going to manage this table. Okay. So now we see the data here, and so from Snowflake to Openhouse to Glue, which is managed through a Spark engine. Then all my ETL work is updates and sort of done. So no more Snowflake in this context. Now, if the Snowflake want to read this table, again, I'm saying read the table, then you're going to connect to object integration. Look at some of the videos in the Snowflake playlist in my YouTube channel. Okay, so that's how you're going to convert. Then we'll start this to Glue. Any questions, send me an email. Then log into LinkedIn on this YouTube. Okay, thank you all. Bye now.